Okay, 7.3, present value, or if you're in the grade 11 mixed course, this would be 8.3. Isolate for P in the actual compound interest formula. So what I want you to do is to isolate for P. What would happen if we made P by itself in this formula? So looking at P, we need to get P by itself. In order to do that, our formula will look like this. That's one way of writing it. This particular formula is the one that's most familiar. In the grade 11 U course, your formula may be slightly different in the book. It actually is this formula. It is P isolated. They tried to make it look different, but it isn't. It is this formula. Or you could have this formula, which I've seen books have. In both the mixed course and in the U course, I've seen the formula with a negative n. That's when we're always looking for P. You'll notice later on that in the PRIN formula, you will also see a negative 1. So anytime we're looking for P equals, whenever we're having P equals, that's when you're always going to have a negative as the exponent. All right, so this particular formula is the Payne formula. The other way the book does it is shown here. This is the way the 3U book does it. It means the exact same thing as this formula. This formula I call the Payne formula. Okay, example 1. Michelle wants to invest money today to have $1,500 in 6 years. If she invests her money at 2.1% per annum, compounded quarterly, how much does she need to invest? That's the key. We need to know how much she needs to invest. So, let's look at all the different pieces that's found in here. First of all, the 2.1% per annum. Look at the quarterly. Look at the 6 years and definitely look at 1,500. 1,500 is, you need this 1,500 in the future, in 6 years. So we need to know how much we have to put in now in order to have the $1,500 in 6 years. So this is a knowledge type question, folks. This is the Payne formula. The reason why it's the Payne is we need to know how much money today. So P is what we're looking for. A is going to be your 1,500. I is 0.021 divided by 4, 4 being quarterly. And finally, N is equal to 6 years times 4, 6 times 4. Plug it into the Payne formula. This is the Payne formula. And you plug it in and you get P is equal to 1,500 divided by 1 plus I, exactly as it is, to the power of N. Plug it in and you get a value of $1,322.86. You need to put $1,322.86 in the account now so that you will have $1,500 in the future. It doesn't seem like much, folks, but don't forget it's being deposited for a short period of time for a very low interest rate. All right. That's it for this section. This is again the Payne formula, and we're now going on to the next one. See you soon.